Okay, ready to dive into some fascinating stuff. We're talking synthetic data, specifically synthetic data for tabular data.
Yeah, all those spreadsheets and databases packed with insights. That's what we're exploring today.
And the star of the show, that's TabDiff, a new approach that's causing a stir. We've got all the intel, research papers, study guides, you name it. We're going to break it down for you.
Why should you even care? Well, imagine training AI models without privacy concerns, or filling in those pesky gaps in your data, or even supercharging your existing datasets. That's the power TabDiff brings to the table.
Okay, let's set the scene first. Tabular data, we all deal with it, right? But it can be a beast. It's not just numbers, it's a mix of data types, complex relationships, sometimes unpredictable patterns. Why is that such a pain to work with?
Yeah, you're right. It's that complexity that makes generating realistic synthetic tabular data so challenging. It's not easy. Like, think about patient data. You've got numerical data like age, blood pressure, and categorical data like gender and diagnosis. It's a tangled web of information, generating synthetic data that reflects all those nuances, not a walk in the park.
Right? It's not just mimicking individual data points. It's about capturing that whole intricate symphony of how they interact. How does TabDiff even approach that?
TabDiff uses a pretty smart combo of techniques, but at its heart, it leverages the power of diffusion models.
I've heard the buzz about diffusion models, but can you give us the elevator pitch? How do they actually work their magic?
Okay, imagine an artist starts with a clear image, right? And then slowly adds noise, blurring, distorting until it's just random pixels. A diffusion model kind of does that with data, progressively injects noise until the original structure is completely gone. But here's the cool part. It learns to reverse that process, gradually removes the noise, to reconstruct the original data's distribution. It's like learning to paint in reverse.
I like that analogy. So it's not just creating noise, it's strategically injecting it and then learning to undo that mess to understand the underlying patterns, right?
Precisely. And that's where TabDiff really shines. It doesn't treat all data the same way. It's got something called feature-wise learnable diffusion processes. So it tailors the noise injection for each column's unique quirks.
Hold on, can you explain that like I'm back in data analysis 101?
Sure, picture a spreadsheet with patient data. One column is age, numerical, right? Another column is their medical condition, categorical. TabDiff knows these need different handling. It's like a conductive, adjusting each instrument's volume in an orchestra for perfect harmony. Each feature, each column, gets the right amount of noise tailored to its type and distribution.
So it's not one size fits all. It's about understanding the nuances of each data type and tailoring the noise accordingly. Clever. But how does it ensure the generated data actually makes sense, that it captures the relationships between features?
Ah, that's where trend comes in. It's one of the key metrics where TabDiff excels. Remember our patient data. Trend makes sure the synthetic data captures the relationship between age and, let's say, blood pressure. Wouldn't make sense for a 20-year-old to have the blood pressure of someone in their 80s, right? TabDiff learns these correlations and makes sure the generated data reflects them.
So it's not just mimicking individual data points, but learning the inherent logic, the rules of the data itself. Let's get into the nitty-gritty, the generation process. How does TabDiff actually spit out this synthetic data?
Think of it like rewinding a film. It starts with pure noise. Then, guided by its training, it gradually removes that noise, revealing a synthetic dataset mirroring your original data structure, like watching a blurry image slowly come into focus.
Okay, that makes sense. But I'm guessing it's not always a perfect, smooth process, is it? Does TabDiff have a way to catch and fix errors?
You're absolutely right. And that's where it gets even more sophisticated. It uses something called a mixed type stochastic sampler, like a built-in quality control system.
Okay, mixed type stochastic sampler. Break that down for me. Sounds a bit intimidating.
Imagine filling in a spreadsheet and you accidentally enter a value that's way off. The stochastic sampler is like a little alert system, nudging the model, hey, double check that. It helps catch inconsistencies, ensures the data is both diverse and accurate.
So it's not just generating data blindly, it's constantly refining and self-correcting. That's pretty impressive. But let's talk proof. How do we know TabDiff actually delivers? What kind of evidence did the researchers provide?
Oh, they didn't just go on gut feeling. They put TabDiff through the ringer, compared it to other state-of-the-art methods using a whole battery of metrics. One of the key ones was shape. It's all about how well the synthetic data mirrors the individual feature distributions in the original dataset.
So it's not just about getting the overall picture, but making sure each piece of the puzzle fits perfectly.
Exactly, and TabDiff aced that test. They also looked at trend, which, as we talked about, measures how well the model captures those relationships between columns. And you know what? TabDiff outperformed the competition there too.
So like judging a painting, not just the brushstrokes, but how they all come together. TabDiff nails both the micro and the macro.
You got it. And to make it even clearer, they included visualizations in the paper. You can actually see how closely TabDiff generated data matches the real deal. It's pretty convincing.
Okay, I'm sold on the science. But let's talk real-world applications. You mentioned this earlier, but can you give us a concrete example, say, for missing value imputation?
Sure. Imagine you're a researcher studying a new drug. You've got patient data, but some lab results are missing. Those gaps can really mess up your analysis.
Every data scientist's nightmare. How does TabDiff help?
Well, instead of guessing or using potentially biased methods, TabDiff can predict those missing values. Based on the existing data, it's like a detective filling in the blanks using the clues.
And because it understands those complex relationships, it's making informed predictions, not just random guesses.
Right, it's like having a medical expert whispering, hey, based on their age, medical history, other tests, their cholesterol's probably in this range. It makes your findings way more accurate and reliable.
A game changer for researchers, especially in healthcare, where those missing data points matter so much. What about data augmentation? How does TabDiff help us create more data, and why is that important for AI?
Think about training an AI to predict customer churn. You know, those customers who leave. You've got data on their past behavior, but it's limited. In AI, more data often means better performance. TabDiff steps in and generates synthetic data, expanding your dataset without compromising anyone's privacy.
So not just cloning the existing data, but creating new, plausible data points that follow the same rules. It's like a master impersonator creating a convincing crowd of new customers based on your existing ones.
Fantastic analogy. And by feeding this augmented data to your AI, you're giving it a richer training ground, leading to more robust and accurate predictions, like giving your AI a crash course in customer behavior so it can handle more scenarios.
So we're talking about more accurate AI models with ripple effects across industries, better customer experiences, smarter business decisions. All this talk about synthetic data and AI is amazing, but it also raises some ethical questions, right? What about the potential downsides of creating data that's almost indistinguishable from the real thing?
You're right. It's crucial to be careful with this tech. We have to be aware of potential misuse. Someone could use synthetic data to create fake news, or manipulate public opinion. That's something we definitely want to avoid.
Like giving someone a powerful tool without a safety manual. How can we ensure synthetic data is used responsibly?
I think transparency is key. Developers need to be open about how their models work, the limitations, and we need clear guidelines, regulations to prevent misuse. It's a team effort. Researchers, policymakers, even the public all need to be involved.
So it's not just about the tech itself, it's about the ethical framework we build around it, using this power responsibly to benefit society. Now, I want to go back to something you mentioned. The paper included visuals showing how close TabDiff's data is to the real data. Can you give us a specific example? What do those visualizations tell us?
Imagine a scatter plot, comparing the real age distribution of patients to the one generated by TabDiff. If TabDiff's doing its job, those two distributions should almost perfectly overlap. It's visual confirmation that TabDiff captures the shape, the trend of the original data.
Like holding a mirror up to the data and seeing a near-perfect reflection. It's not just numbers matching up, it's the whole pattern being preserved. Now, we've focused a lot on the technical side, but I'm curious about the human side. What are some potential societal impacts of this technology? How could it change the way we live and work?
That's a great question. I think the potential impact is huge and it touches on so many things. For one, it could totally change how we approach research and development. Imagine doing clinical trials or testing new products using synthetic data, data that accurately reflects the real world without putting anyone at risk.
That's a huge leap forward, especially in fields like medicine where safety and ethics are so important. And it's not just about mitigating risks, it's about accelerating progress, right?
Right. Synthetic data helps us overcome things like data scarcity, privacy concerns. Those things often slow down scientific progress. It's like unlocking a treasure chest of possibilities.
Sounds like we're on the verge of a new era where data isn't a limitation but a catalyst for innovation. And TabDiff is one of the pioneers leading the way.
It really makes you wonder what other applications are out there that we haven't even thought of yet. It's like we've got this blank canvas and these amazing new tools. Who knows?
Things like using synthetic data sets to tackle climate change or to personalize education or even, I don't know, compose symphonies. Okay, maybe I'm getting a little carried away, but the possibilities seem pretty endless. But before we wrap up, let's zoom out a bit. Where does TabDiff fit into the bigger picture of AI and data science?
Well, TabDiff is definitely a big step forward in the world of generative models. These models are all about creating new data that reflects the real world. It's a field that's just exploding.
not just about analyzing data anymore. It's about AI learning to create. That's pretty profound when you think about it.
It really is, and it's not just limited to tabular data either. We're seeing these generative models making huge waves in things like image generation, music composition, even drug discovery.
Like AI is discovering its creative side, pushing the boundaries of what we thought was possible. What are some of the most exciting frontiers in this field of generative models? What's got you excited?
One area that I find really fascinating is the development of what we call multimodal generative models. These are models that can generate data across different modalities, like creating an image from a text description or the other way around.
So instead of just text or just images, they can weave together different types of data, create something much richer.
Exactly. It's like teaching AI to understand and communicate like we do, using words, images, sounds, even emotions.
That's amazing. It opens up so many possibilities for how we interact with AI and how it can help us understand the world.
And it's not just about creating things that look or sound real, it's about creating things that are meaningful, that are useful. Imagine, using these models to design personalized education or to create immersive virtual experiences, even develop new art forms, new entertainment that blurs the lines between reality and imagination.
The creative potential is huge, but we have to talk about the ethical implications too. As these models get more powerful, how do we make sure they're used for good? What keeps you up at night?
That's a question I think about a lot. One of my biggest concerns is the potential for these models to make existing biases worse. If we train them on biased data, they'll just reproduce those biases in whatever they create. It's like giving a megaphone to prejudice.
Garbage in, garbage out, right? It's not enough to just focus on the technical brilliance. We have to pay attention to the ethical side too.
Absolutely. We need ethicists, social scientists, policymakers, all working with computer scientists to make sure these technologies are developed and used in a way that benefits everyone.
It's a good reminder that technology is never neutral. It reflects the values of the people who create it. It's up to us to guide it in the right direction.
Well said. It's not just about what the technology can do, it's about what we choose to do with it. That's where the real power is.
I love that. Okay, last question. If you had a magic wand and could use TabDiff to solve one problem in the world, what would it be? Something you really care about.
Ooh, that's a tough one. If I had to choose, I'd probably use TabDiff to speed up the development of personalized medicine. Imagine being able to create synthetic data sets that capture all those unique factors that affect how people respond to treatments. Their genes, their environment, everything. It could completely change how we diagnose and treat diseases. More effective therapies, better outcomes for patients.
That's a beautiful vision. It really shows how this technology can improve lives.
It's a future worth fighting for, and I think tools like TabDiff are bringing us closer.
I'm optimistic too. I can't wait to see what we can achieve with this new power to create. This has been such an insightful deep dive. Thanks so much for joining me and sharing your knowledge.
It's been a pleasure. I really enjoyed the conversation.
And to our listeners, thanks for joining us on this exploration. We encourage you to learn more about synthetic data and generative models. There's so much to discover. Until next time, keep those minds curious and stay tuned for another deep dive.